This is Algebra 2, Lesson 13-5, Exponential and Logarithmic Forms. So this is an interesting lesson because it's basically a scaffolding lesson, meaning by itself, it's not super useful, but it is a tool that's going to be used over and over again through the rest of the unit that will be useful. So that's kind of what I said at the very beginning. Being able to switch between exponential and logarithmic form will be a tool to help you solve problems in the future. It seems like right now you're just kind of doing a thing and not knowing why. In the next lesson, I will be showing you why we are doing the thing. Okay, so there are two different forms that you should know. The first one is familiar to you, the exponential form. You have a base to a power is equal to an answer. Over here, these are the same numbers, base, answer, and power, but in a different form. It is logarithmic form. If you can't say logarithmic form, say it fast and no one will know. Logarithmic. So the way that you pronounce this thing is log base b of a is equal to p. Notice that log a and p are all on the same line, but b is kind of below the line. It's called subscript. So it's technically log subscript b of a is equal to p. And they mean the same thing. So what this means to us, if you want to switch from one form to another, essentially the b, the base, is always on the bottom. It's either the base of the bottom for the logarithm or it's the bottom of the exponent. And then the power and the answer here just switch directions. So you can say that over here, the a and the p are on the opposite sides. A is on the right and b is on the left. Or sorry, p is on the left. So I can say a is on the right. A was on the left, and now it's on the... Sorry, I can't speak. A was on the right, and now it's on the left. P was on the left, and now it's on the right. So they just switch directions. But B, the base, always stays in the same spot. So another thing that will help you on the homework especially, sometimes on the homework you'll see, you're missing a power down here. You're missing the base down here. What's going on? It's not the power, it's the base. So if you don't see any sort of base for a logarithm, it's technically a base 10. And not on the homework, but on a quiz or a future problem, you might see this weird ln thing. It looks like a logarithm. It has the same form as of a logarithm, but again, it's missing its base. So this is technically a natural logarithm. It's backwards because back in the day, we used Latin, which is kind of like Spanish, where the noun comes before the adjective. So it's like logarella naturala or something like that. So that's why it's backwards, but it is natural log, and the natural log has a base E. We'll talk about E on another date. So we have all of our notes out of the way. We know the different types of notation where we have hidden bases. Let's jump into 4 example problems. These go really quick, guys. So if I have something that is in logarithmic form and I want it in exponential form, I keep the base 4. So I have a base of 4. And then I switch the 3 and the 64. So 3 is on the left. This is to the power of 3. And the answer is equal to 64. And you can verify it indeed for some of these problems where you don't have a bunch of variables. Like that's a bunch of variables where you can't verify it. But these two problems right here, you can verify this actually works. 4 cubed is indeed equal to 64. If you don't have that memorized, you should go practice your perfect cubes on Blue-Kit. Over in example 2, you're going to do the same thing. I have a base of x, so I have a base of x. Again, I'm going to switch the 77 and the y, so the y is now on the left-hand side. So this is x to the power of y, and the answer is equal to 177. Let's try example 3. Again, I have a base of 9, but now I want this in logarithmic form, so I need to practice writing log. So in my class, I write log with the cursive L. The rationale behind that is if I were to accidentally write ln as ln like this, I typically write my L's with just a line, but my lines and my ones look exactly the same. This is 1, 2, 3. This is LMN. My ones and L's look the same, so just to distinguish that in my handwriting, I do cursive L's whenever there's maybe confusion. This might be confused as the number 1, then the variable n. So to make sure that I don't accidentally confuse that, I use a cursive L. It's much less confusing when I write out LOG, but sometimes there's also composition of function where you do L composition with G, and that is not pronounced log. This is pronounced L of G. So there's a lot of notation in math. So just to be careful with mine, I'm going to write my logs like this, and I encourage you to do the same. So I'm going to write log. I have a base of 9, so this 9 is going to come down here for my base of my log function. Log base 9 of what? Again, now this 1 over 81 is going to switch sides. I have 1 over 81 on the inside of the argument, and then on the right side, I have to switch the -2 to be on this side. I have a -2. And you can verify that 9 to the -2 is 1 over 81, but it's a lot harder to verify logarithms since we don't know how to do that until the next lesson. In example 4, in example 4, I'm going to do the same thing. I need it in a log form. Let's write this in pen. So it's going to be log base what? Base of the exponent. So it's going to be base 13. And then again, I switch my negative x and my y. So it's going to be of my argument y is equal to my negative x. So that concludes the lesson 13-5 for exponential and logarithmic forms. Thanks for watching.